explain the concepts called data types, variables, arrays in Java. In continuation of the previous video, so now I'm going to explain the concept called data types. Okay? In Java, so it is going to define 8 primitive data types. Okay? One is with byte, short, int, long, float, double, boolean, and then char. So the primitive types are also commonly referred to as simple types, and both the terms will be used in this subject. Okay, so we are going to put in it in 4 groups. Okay, one is with the integers, and second one is the float, and third one is the character, and fourth one is the boolean. So whereas coming to this integers, so this group includes the byte, short, integer, and then long. So which are all for a whole valued sign numbers. So these all comes under the integers type. And next, floating point numbers. So coming to this floating point numbers, so this group includes the float and then double. So which is going to represent the numbers with the fractional precisions. And next, coming with the characters. So this group includes the character which represents the symbol in a character set like letters and the numbers. Next, with Boolean. So this group includes Boolean, which is a special type of representing either true or false values, or else our own specifications. Okay. So this primitive types represents the single values over here, not the complex objects. So although Java is otherwise a completely object-oriented, the primitive types are not. Okay, so here, regardless of this particular platform, so it is allowing us to guarantee that. So for specifying the any primitive type as a, that means we are having an option to use any primitive type in our Java language. Okay, so here it has been specified with the sizes of each data type and its ranges also. That is where it will be starting with this representations. If you come across with a byte, it is with the size of 1 byte only. That means 8 bits. If it is with the short, it is 2 bytes representation. Integer in this is 4 bytes representation. Long in this is 8 bytes representation. Float in this is 4 bytes. And then double 8 bytes, boolean is 1 bit. That means it is a representation of either 0 or 1. No, so that's why it has been represented with 1 bit representation. And then character in this is 2 bytes. Okay, so whereas coming with this ranges, if it is that means actually we can say the smallest integer type is byte only. So this is a signed 8-bit type that has a range of -128 to 127. Okay. Variables of type byte are especially useful when you are working with the stream of data. So from a network or else a file. For example, we can able to specify the variables B and C with the byte B, C. So like this, we can able to specify this one. Whereas coming to the short, it is assigned 16-bit type. So it has a range of -32,768 to 32,767. So it is probably the least used Java type. Next, coming with integer. So the most commonly used integer type is Jntuh. So it is assigned 32-bit type that has a range of this, that means complete the whole numbers. So it will be ranging from this. So 2147483648 minus value to the positive value. That is negative value to the positive value. Next with long. So long is a signed 64-bit type. So and is useful for the occasion where an integer type is not large enough to hold the desired value. So whenever it is not large enough to hold the desired value, then only we will be making use of this long value. Next, coming across with the floating point types. So floating point types are only 2 types, float and double. So float is going to specify a single precision value that is going to use 32 bits of storage. Single precision is faster on some processors and it takes half as much as space as double precision. Okay, but will become imprecise. So when the values are either very large or very small. So whereas coming to the double precision as denoted by the double keyword, which is going to use 64 bits to store a value. So double precision is actually faster than a single precision on some modern processors. So next, characters. So here in Java, data types are used to store the characters in char. Okay. So the standard set of characters known as ASCII still ranges from 0 to 127 over here. Okay, as and that will be ranging from, that is actually the ISO Latin one is ranging from 0 to 225, but whereas ASCII ranges from 0 to 127. Next, coming with Boolean. So Boolean is also a primitive type which comes under the type called Boolean only, okay, for logical values. It can have only one of the two possible values, that means either true or else false. Okay, so the representation is in between the true or false representation. So these are the 8 primitive data types that has been categorized into 4 types: integer, float, char, and then boolean. Under that integer, so byte, short, integer, long will comes under the integer category, whereas float and double comes under the float category, and character and then boolean. Next one is variables. See, the variable is the basic unit of storage of the Java program. So we are saying that the variable is a basic unit of storage in the Java program. A variable is defined by the combination of an identifier, a type, okay, and an optional initializer. So in addition to this, all variables have a scope which is going to define their visibility and also the lifetime. So this is how we are going to declare a variable. So this is the syntax of declaring the variable or else creating a variable. That is type. We need to define the type of that variable. So we have gone through the 8 primitive types of specification. So that type we have to represent, and then the variable name, and then what is the value over here. So this is how we are declaring the variable. And coming to this dynamic initialization, Java allows variables to be initialized dynamically also. So using any expression which is valid at the time the variable has declared, we can also give the dynamic initialization of the variable also. Okay, so to create a variable that should store text, so here I have been represented with a small example. See, to store the text, that is to store the string of variable. Here I'm specifying the string, okay, and then I'm going to specify the name of the variable as name, and here I'm storing the value called jar. Okay, so this is how we are going to specify the name of the string. That means first of all we need to specify the type, and then we need to specify the name of that variable, and then finally the word which we want to give. Okay. So before going to this one, so far all of the variables we have been used have been declared at the start of this main method only. Okay, so usually, so this Java allows variables to be declared within any block. Okay, so usually we are going to declare the start of the main method. That is, we are going to declare the variables at the start of the main method. However, so Java is allowing us to declare this variables within any block. Okay, so that's it. That is about the variables. Next, with the type conversion and casting. So this type conversion and casting. So if you are having any previous knowledge on this any programming language in the sense, then it is very easy to understand this type conversion and casting. Okay, that means we are trying to convert one type of that means one primitive data type into the another one. Okay, that means if it is an integer in the sense, we are trying to convert it into this. For example, if it is a character in the sense, we are trying to convert into the integer, and if it is an integer in the sense, we will be trying to convert into float. If it is a float in the sense, we will be trying to convert into the double like that. Okay, so here we can able to discuss in a two types of conversions. One is in a widening way and another one is a narrowing way. So widening way in the sense, as we have already discussed with the sizes of each and every primitive data type. Okay, so widening in the sense, converting a lower data type to a higher data type is nothing but a widening. Okay, here we know that so byte size is 1 byte. No, so it has been going to get increased over here. Okay, that means lower data type has been converted into the higher data type. That is nothing but a widening. Okay, so here the conversion is done automatically. So this conversion is nothing but an implicit typecasting. We are calling it like an implicit typecasting. Okay, so here converting. Next concept is narrowing. So this narrowing is nothing but converting a higher data type to a lower data type is nothing but a narrowing. So in this case, the casting is not done automatically. Whereas here, as it is a lower to higher, the conversion will be done automatically. But whereas in the narrowing, that means from higher data type to the lower data type conversion, so it is not done automatically. We have to convert. Okay, so that type of conversion or that type of casting is nothing but an explicit type casting. So where the flow will be like from double to float, float to long, long to link, to short and short to byte over here. That means complete reverse to the widening is nothing but the narrowing. Okay, but here the coming to this widening, the range will be from lower data type to the higher data type, whereas narrowing is nothing but higher data type to a lower data type over here. So that's the type conversion and typecasting. So type conversion is nothing but converting one data type to another data type is nothing but conversion. Okay, so we are having that much flexibility to convert the data type in the middle of the program also. Next concept is arrays. See, an array is nothing but a group of like type variables. That means we can say it is a similar type variables, so that are referred by a common name. Okay, an array is a group of similar type variables, so that are referred to a common name. Okay, so arrays is of any type and can be created. Okay, so it may have one dimensions or else more than one or more dimensions. Okay, it can be created of any type. Arrays can be created of any type over here. So array in the sense it is a group of similar data type. Okay, so the specific to a common name. And a specific element in an array is going to get accessed by its index. Okay, so for example, if we are going to declare a set of values in that array in the sense, based on its index value, we can able to access the element. For example, I'm going to define the array size as 5. Okay, so if I want to read the element that is present in the third position in the sense, here the third position will be acting as an index of that array. So whatever the value that is existing in the third position, it will get accessed. Okay, so that is how we are going to use the array. And arrays are created on dynamic memory by JVM. Okay, so Java Virtual Machine is going to create the arrays on dynamic memory. Okay? So there is no question of static memory in Java. Everything is created on dynamic memory only. Okay, so an array is going to represent a group of elements of same data type. Okay, so arrays are generally categorized into two types: single dimensional arrays and then multi-dimensional array. So that multi-dimensional array will come with two or more. That is 2D, 3D like that. Okay. So how we are going to define an array? How we are going to declare or else create an array in this sense? So we need to specify the type, okay, and then within this braces, okay, so we need to specify the braces and then we need to give the variable. Okay, so that means with which variable we are going to define the array. Okay. Or else we can also give like we need to specify the type over here and then we need to specify the variable name. Here we can able to declare the size. That means this is an example. If you observe this example, you will understand clearly. Okay. Here I'm specifying the data type as integer, and if I want, I can specify the size of the array here and then the name of that array. In the same way, if I can able to create an array like this, or else I can just specify the first data type and then followed by the name of that array, followed by the size. So these both syntaxes we can use. Okay. So here we are just not specifying any memory allocation at this point. Okay. So in Java, so we can allocate memory for variables with the help of the new keyword. Okay. Again, if you see this syntax, here I have represented the syntax for specifying the memory allocation. So that means variable name, new, its type, and then specifically that means size of that array. Okay, here I haven't mentioned any memory allocation. Okay, I've just mentioned we have just declared a array variable. Okay, after the declaration of that array, so here I'm going to specify the memory allocation. Okay, if you observe here, so primes is the variable name, that means array name over here. Then I'm using the new keyword for allocating the memory, and I'm specifying the integer with the size of 10. Okay, so this is how we are defining and then declaring this arrays over here. Okay, if at all the case, if the case we want to define in the sense, we can also specify the size over here like this. That means we need to specify the type integer. Okay, so then we need to specify the variable name, next new keyword, and then type, next size. That means memory allocation. Okay, so as it is an integer, so it is going to allocate 40 bytes of data. Why? Because each and every integer is of size of 4 bytes, and here we are trying to allocate 10 values over there. So we have just multiplying the 4 bytes of data with 10 values, then totally 40 bytes of memory allocation will be done for this primes. So next coming with the default initialization. So when an array is created, so array elements are initialized like numerics or else boolean or else character or else class type. Okay. So as I mentioned that we are having this various types of dimensional arrays, right? Single dimensional and then multi-dimensional. Under that three-dimensional, again we are having the 2-dimensional arrays and then 3-dimensional arrays. First of all, what is a single dimensional array? A one-dimensional array is essentially a list of similar type variables. To create an array, you first must have to create an array variable of desired type and its general form. That means whatever we have discussed over here is nothing but a single dimensional array. So this syntax and all representation all comes under the single dimensional array. Okay. So whereas coming to this multi-dimensional array, firstly with the 2-dimensional, a 2-dimensional array is a combination of that means 2 or more 1-dimensional arrays. Okay, so that means a 2-dimensional array is going to represent several rows and columns of data. To represent that 2-dimensional array, we should use 2 pairs of square braces over here after array name. So we need to make use of 2 square braces. Okay, for example, this one float is equal to float 2 square braces, then the name of that array. Next, so we need to allocate memory. No, so we are using new keyword, then next float, and then we need to represent the rows and then columns. Okay, so here the 10 arrays each having the 365 column elements. That means, so 10 rows is having the first index is going to represent the row over here, and the second index is going to represent the column. Okay, that means 10 rows and 365 columns. Okay, so as it is a float, here it is going to specify the 4 bytes. So we need to multiply, so 4 with 10 and again with 365, so that how whatever the value we are getting, that value of memory is allocated for the two-dimensional array. If you come across with this three-dimensional array, okay, so we can consider three-dimensional array as a combination of several two-dimensional arrays. To represent this three-dimensional array, we should use 3 square bases after the type. Okay, so we declare three-dimensional array directly to store the elements at the time of its declaration. Okay, either we can go with that one or else we can go with the entry over here. Okay, so this is the syntax for representing the three-dimensional arrays. Next one is operators. Okay. So we are having a set of operators in our Java language. Okay. So Java is going to provide a rich set of operators to manipulate the variables. Okay. So we can divide all the Java operators into these groups. Okay, whatever the operators we are having, so we are going to divide that operators into these groups. So first one is the arithmetic operators, next one is relational operators, next one is logical operators, bitwise operators, shift operators, and then ternary operators. Okay, so first one is the arithmetic operators. So these arithmetic operators are used in mathematical expressions in the same way that they are used in algebra. Okay, so we'll be having this operator called plus, minus, star, and then division. Okay, next modular division, and then increment and decrement. Okay, precedence, and then assignment operators. Okay, so however it is performing the operations in general mathematical expressions, in the same way it is going to get performed. See, if you represent with the plus in the sense, it is nothing but addition. It is going to add values on either side of the operator. In the same way, subtraction. So in the same way, multiplication, division, and then modular division. Whereas coming to the increment and decrement, it is if it is with the increment in the sense, it is going to increase the value of operand by 1. If it is a decrement in the sense, it is going to decrease the value of operand by 1. Okay, this is with the arithmetic operators. If we are coming across with this relational operators in the sense, okay, so we will be having double equal to, less than, greater than, less than, equal to, greater than, equal to, and then not equal to. Okay, so if it is with a double equal to, it is going to check if the value of two operands are equal or not. If yes, then only the condition becomes true. If it is a not equal to in the sense, it is going to check if the values of the two operands are again equal or not. If the values are not equal, then only the condition will become true. Okay, next, coming across with the greater. Okay, so it is going to check if the value of the left operand is greater than the value of the right operand, then only the condition will become true. In the same way, complete reverse to this right operand is nothing but less than. Okay, it is going to check with the value if the left operand is less than with the value of the right operand. Next, greater than equal to in the sense, it is going to check the value of the left operand is greater than or equal to with the value of the right operand. In the same way, less than equals to also. Okay, so this is what the relational operators is meant for. Next, with logical operators. Okay, so logical, so we are having these are the logical operators. Okay, and or and then not. Okay, so this is called the logical and. This is the logical and operator. If both the operands are non-zero, then the condition will become true over here. Okay, we need to take A and B. Okay, so if both the operands are non-zero, then the condition becomes true. Whereas coming to this logical OR operator, if any of the two operands are non-zero, then the condition becomes true. Whereas coming to the NOT, logical NOT operator in the sense, so it is used to reverse the logical state of its operand. Okay, if your condition is true, then logical NOT operator will make false like this. Okay. Next one is bitwise operators. So Java is going to define several bitwise operators, so which can be applied to the integer types, long and then integer, short, character, and also byte also. Okay, so here bitwise operator works on bits and performs bit by bit operation. Okay, so here we are having the so many operators. Okay, so this is the binary. One's complement operator is unary and has the effect of flipping bits. So we can do the flipping with this symbol. Okay, and this is the binary AND operator, which is copies a bit to the result if it exists in both operands. And this is the binary OR operator, which is going to copy a bit if it exists in the either operand. And this is the binary XOR operator, which is going to copy the bit if it is in the set in one operand, but not both. Okay, so this is with the bitwise operators. Next, coming across with the shift operators. So shifting in the sense, so here we are trying to change the positions to the either to the left, okay, so to the right. So to which value it has to get placed. Okay, so just we are trying to shift the positions over here. That is nothing but the shift operators. See, next coming across with the operator precedence. Okay, so the priority which we are giving for the operators here I have just mentioned. First for the parenthesis, so next to the increment and decrement, next to the multiplications. Okay, so this is from left to right only. Next to the additive, next relational, equality, next logical and logical OR, and finally the assignment. Okay, so this is the precedence we need to follow whenever a statement is going to get executed. Okay, so this is all about the operators and its precedence and then priorities which we need to give for each and every operator. Thank you.